So I should make a note that it's basically the structure of both of the classes, like the token stream and this node, it's just trivial. What may be non-trivial or somewhat less trivial is the way we intend to use these classes, right? So the node we're going to use to construct trees, and the token stream we're going to use as navigable set of tokens that we want to proceed with. So back to I should say, remaining challenge in this application is, of course, how do we deal with grammar rules, right? Basically, grammar rules for arithmetic expression. Okay, so let me show you the approach that I took in order to now being able to interpret these tokens and validate them against the rules of arithmetic expressions. So the idea that I took is that generally speaking, we can qualify this entire program. I don't know if I have an example of our expression anywhere here. Basically, the structure of this entire program, its architecture, will be called or can be qualified as recursive descent parser, right? Because it says, I will deal with every single token and proceed with the rest of pluses and minuses and things alike. But anytime I see parentheses, I'm basically going to restart myself, because I'm going to say, oh, everything inside parentheses should be done as if this was done outside of this entire expression, and then we will come back to the rest of the expression. So essentially, there is basically a re-entrancy into everything that we need to do with understanding expressions. And so with this in mind, let me show you that what I did here is that at the end of the Selexer class, which so far we looked at its constructor, right, which constructs the token stream, and its start rule, which basically starts off the things. At the bottom of this file, I put together a set of something I refer to as a set of syntax rules, or grammar rules, to deal with expression, with arithmetic expression. And I would encourage that you actually, after today's presentation, when you go to the handout assignment, that you can basically read the comments I placed over here. So perhaps even here it may be a better view of the way we're going to approach arithmetic expressions. Okay, so this is what I decided to do. And so typically, an arithmetic expression, which is highlighted there at the top, okay, is basically a set of pluses and minuses which have the lowest precedence compared to multiplication and division, right? And so we say that the expression could be split into parts that are basically linked by pluses and minuses. So, for instance, a valid expression is, all right, maybe what I can do is just, again, demonstrate this in parallel in my demo here. Okay. So the idea is the simplest type of expression may be the user just types the number, such as 1, 2, 3, right? This is a legal input. It's a legal arithmetic expression, right? So therefore, we have these set of rules that basically we begin to understand, is this an expression? Okay? We need to determine, is 1, 2, 3 an expression? Question mark. So the set of grammar rules says that it can be a term. Okay? Because the first thing that happens here in this set of rules, it says that it can be a term. In some textbooks, the term can also be called a factor, which is the result of like multiplication or division, right? So that's the second name typical name for the term. So the term is a separate rule, and I need to spell it right. So the term is a separate rule. And now we say that basically is 1, 2, 3 a term? Okay, question mark. So the term says that, oh, the term could be a primary. Okay, and the primary is a separate grammar rule, such as primary over here. So first we're going to say, is this a primary? And the primary says, what is primary? Primary can be a number, okay? Or it could be, primary can also be an unary minus, like minus 1, 2, 3, or unary plus, like plus 1, 2, 3, which is simply 1, 2, 3, without even any kind of unary operator, right? Or it can be an expression enclosed in parentheses. And later on, we can also discuss assignment statements like this. But for now, you can see that if I'm using this approach by saying, is term a primary, then the first thing that comes to mind here, number. And I can check the current token for the number, and guess what? The number will say yes, it's a number. 1, 2, 3 is a number. We were able to identify it as part of our grammar, number 1. So now the primary is happy, and the primary, instead of this question mark over here, right? So instead of this question mark, the primary will return something and will say, yes, there is a match. Primary was found. Now the term over here, which initially wanted to check whether it's a primary, right? It will say, oh yes, I am a term because the primary was able to match, and we return back to the expression, so the term will be matched, okay? And then the expression says here, well, you know what? Once you match the number such as 1, 2, 3, which was at this level really primitive, really trivial, like number. Oh yeah, we can compare 1, 2, 3 type of string with the number and say yes, it's a number, right? So at the next stage, expression says, well, maybe we're not done yet. How so? The rule says, okay, if it's a single term, it's one thing, but the term can be term plus another expression. Okay, all right. So what does it mean? So we basically want to say that the term is can be followed by the plus, literal plus, syntactical plus found as a separate token, followed by another expression. And in our example with 1, 2, 3, of course, with this example of 1, 2, 3, of course, there's basically the end of input, so we can largely ignore any other additional rules with an expression and say, yes, it's an expression because the term was able to match that it's a primary, and the primary, of course, was able to match because 1, 2, 3 is the number. Okay, moving on. Another example of input. Another example of input over here may be that I'm dealing with expression such as 1, 2, 3 plus 4, 5, 6. Let me just be more careful. 1, 2, 3 plus 4, 5, 6. Okay, so this type of expression. 1, 2, 3 plus 4, 5, 6. So what's going to happen in this situation, again, our quest for passing or failing grammar rules will be by saying, is this whole input an expression, question mark? And the answer will be yes, if, let me actually get rid of this as well, just to keep this stuff clean, right? And the answer will be yes if we can say that it's a term. The term will go to the primary. The primary will check 1, 2, 3 and determine that it's a number, right? And then it will come back and say everything works well so far. And then we're going to check, was there a plus following the number? And of course the input will say yes, there is one. So this plus will be actually consumed at the expression level as a symbol. And of course the signal for us to construct this node, which will have left and right type of thing. And it will then say that, and it should be followed by another expression. In that sense, we basically just go and call ourselves and say, is there another expression? The result of it is that we can basically say that expression will be happy if we deal with situations such as term plus another term, minus another term, plus another term, and so forth. This is what the expression level understands, right? Because what it's going to be doing is just basically going to be saying, I am going to match the term, right? I'm going to match the term, and as long as there's a plus or minus following it, I will go ahead and proceed to assume there is another term plus something, another term plus something. But eventually, look what happens. We get to the point where 4, 5, 6 also will be matching the term because it's a primary, because it's a number, okay? And what's going to happen is that after this, there is no more input, and we will say, okay, can we stop at this point? And the grammar rule will tell us, yes, you can, because it's okay to deal with an expression which only consists of a term without following the plus or minus. Overall, together, this type of rule is considered to be a right-hand side recursion, right? Because it says, I'm going to match something, I'm going to try something else or something else, but I'm not going to stop at this point. I'm going to try it again and again and again and again. And it just basically is going to be able to, as a result, the expression should be able to successfully deal with inputs such as, basically, let me clean this up a little bit. All right. So the expression should be able to deal with successfully with inputs such as term plus term, term minus term, term minus term plus term, and things like that, right? So that's the responsibility of the expression in our grammar rule. It will match any of this because it says, as long as I do find plus or minus, I know what to expect next. It's going to be another expression following it. Okay, all right. So, right now, what we have implemented in our first version of the demo is basically another type of primary. Besides the number, it will also match the set of parentheses. And so now obviously is the time to actually look at the code and see what the implementation of these grammar rules are.